Man, it's making me feel old. I'm telling you.
Make me
110,
feel
over
old there.
110.
110. Okay. All right. It still makes me
Yeah,
feel old.
over. I added it up,
Over.
but y'all
Well,
all have plus, plus, plus. So
one of my favorite things I tell people is I'm not very smart. I just been around a long time, been through the school of hard knocks. So,
Yeah.
but so well, welcome to our class this afternoon of the cable pull calculator. And we only have a few folks on the call this morning. So Elizabeth, if you want to just make everybody panelists, we'll rather than make this just a presentation, we'll kind of do this interactively a little bit, and we'll talk about some things along the way.
yeah. Hey, Johnny,
And
I'll interrupt you for 2 seconds, but
yes.
I just noticed this morning that if I promote you guys, you can actually share your video too. So I guess I'll go ahead and do that. I can allow you to talk. What do you guys think about that? Show
Yeah,
video or just talk?
Can they unmute themselves, Elizabeth? Is there?
Yes.
Okay. Yeah. So if you get at the point where you'd like to
think-
stop, talk about something for a minute, just feel free to unmute yourself and say, hey, hang on a second, let's discuss, because again, it's a small group here, so we'll kind of make this interactive today.
Okay.
All right. That said, I'm working from home, so my bandwidth is less than great. So I'm going to go ahead and turn off my video here so I can have a better chance at my audio working properly. All right, so we got that. All right, so today we're going to talk about the cable pull calculator and how this really has a really tremendous impact on how easy or how difficult that these cable pulls are that we do. And today is going to be kind of an overview of this thing to give you an understanding how it works. If you want to learn more in depth of how to do this tool, we're going to have future classes. It's about an hour-long class of showing you the details of it, and then probably another hour-long class to follow up of getting the hang of it. So today's kind of an overview of it, and how it matters and why you can make it work for you. So let's see if I can get my technology to work here. There we go. You think about wire pulls. We get out on a job and you hit the ground running, and you start putting conduit in the dirt, or you start putting conduit in the air, and you tend not to think too much about how you're going to pull that wire because, well, the wire is going to go on a conduit or it's going to go in a cable tray. But the reality of it is, and one of the most important concepts here from today is we really got to think about wire pulls in the pre-construction phase of the project. How do we plan these raceways in a manner that it's going to make this wire much easier and much safer to pull? When we do that, it's going to make our job much safer and easier. So we want to be thinking about this in pre-con. So when you get that next job coming up, you want to start taking a look at your electrical rooms, take a look at your feeders, and think about how you're going to get from point A to point B, and do some of these pull calcs before you start running this raceway. So we'll talk about that a little as we go here. So how do you get this tool? It's free for you. You can go to southwire.com, go to our resources page, and you'll see our tools. And you can download for desktop, which is going to be an Excel-based spreadsheet-driven tool. We have I guess what I call a scaled-down version or a mini version of it that you can get on your Android or your iOS and use some things there. But the spreadsheet's really going to be the workhorse for these cable pull calcs we do. You get a whole lot more functionality in that tool, and that's what we're going to focus on today. So pre-construction planning, as I mentioned earlier, the raceway, the way it's installed makes a big difference on how easy or how difficult a wire pull can be. And most of you you ever pulled a wire, you know the answer to that. It makes a huge difference. The number of elbows you have to go around, where you set up for the pull, where you get your wire in place. So it makes a big thing. So we're going to go through some of the factors that impact wire pulling, and we're going to allow us to use this tool to build and plan an entire wire pull. And when we do that, we're going to eliminate damage of wire. We don't want a wire to get damaged while we're pulling it. We don't want the wire to get stuck in the raceway, so we're going to eliminate stuck wire pulls. And doing this, we're going to be able to pull further through more elbows in one shot than we have before, and we're going to eliminate splices and backfeeds in most cases. This all translates into reduced time, less time and effort. It's going to eliminate rework. The safety improves dramatically because you got less people in harm's way handling these difficult reels and having to make splices and do back feeds. We're going to choose the proper equipment. That less effort to do the pull is going to drive profits to the company. You know, and as Bill and Joe talked about on the if you were on the presentation this morning, labor is such a big deal right now. There is a growing shortage of manpower in our industry, and the more we can do here to reduce the time spent on wire pulls is dramatic. You know, it has a dramatic impact on what we do. You know, we have example after example after example of contractors who take advantage of Southwire Solutions, doing the paralleling and the stacking and all the things that Bill and Joe talked about earlier this morning. And then you apply that, use the pull calculator to plan these pulls. And you know, you look at some of these feeders that might be 3 weeks worth of wire pulls that you can do in 3 days with half the manpower. So it's a tremendous difference. So just want to point that out. Okay. Let's talk about a few of the things that impact wire pulls. The first one is coefficient of friction. We call it COF for short. Well, what is it? Coefficient of friction really is just a measurement of how slick the wire is, right? It's just you pull the wire through the pipe, and it has resistance to the conduit sidewalls, and it takes, you know, it's a measure of the slickness of it. I kind of make an analogy of a tennis shoe or a dress shoe. If you're wearing a tennis shoe and you try to slide it across the floor, it's not going to slide very easily because it has a high coefficient of friction. And you take your dress shoes that's got that leather sole, and it's going to slide pretty easy across that floor, across that carpet. It's got a low coefficient of friction. So that's the difference. We have a very, very low coefficient of friction. And that's something that we measure. We test it and we know what that is. And our wire, we say, stop, do not lube the wire. You don't put a drop of lube on our SIMpull wire. Folks ask, is it going to help if I lube it? And the answer is no. People ask, is it going to hurt if I lube it? And no, it's not. You know, if you want to waste time and effort on lube and all the safety hazards that go around with making the floor slick, but there's no need in it anymore. You just don't do it. So the coefficient of friction matters, the weight of the cable, right? Copper's heavier than aluminum, right? So the weight of that cable makes a big difference. If you're going vertical, the weight's working against you, gravity's working against you. If you're going down, gravity's working for you, right? So that's another big thing that impacts the wire pull. Next thing is pulling tension. And these are again things that we calculate when we do these wire pulls. Pulling tension is really just the force necessary to move that wire through that raceway. And that's what we have our ropes and our wire pullers for. And we generally tell you we don't want to exceed more than about 10,000 pounds of pulling tension on that wire. You know, you exceed that, and you're going to begin to cause damage to that wire. You're going to begin to stress that insulation and stress that conductor. So pulling tension is something that we have to look at. And quite frankly, pulling tensions with the wire we have now and the really, really slick ropes that we have now, pulling tension is not usually the issue. It's something else that gets us, but pulling tension is a consideration. Here's the thing that's going to usually be the limiting factor on these wire pulls, and it's called sidewall pressure. Well, what is sidewall pressure? Well, it's really pretty simple here. If you look at this picture here at the top, you see two conduit elbows. The one in front is a longer radius elbow. The one in the back there looks like it's field bent, but it's kind of a factory standard 90-degree radius elbow. Well, sidewall pressure really means that as you pull that wire in that pipe, the further you go and you go around these elbows, you're pulling more weight of wire through that pipe. And as it goes around the bend in that elbow, it's going to exert pressure on the inside radius of that elbow. And we call that sidewall pressure. And if you exceed around 1,000 pounds of sidewall pressure, you're going to damage that cable going through that elbow. If you see in the picture below, that's an example of some medium voltage cable that was damaged because it exceeded sidewall pressure, and it literally tore the jacket and the tape shield off that cable. So sidewall pressure is the thing that's generally the shot that's going to get us on these wire pulls. So what else do we look at? I'm not going to cover too much about this today. This is incoming tension. Incoming tension is the amount of effort it takes to turn the wire and get them to come off those reels, to turn those reels and get that wire moving. As you see in this top picture, this is I love to show this picture because this is an example of the old days where you had all these individual spools of black wire set up here. You had all these jack stands set up, and that wire is dragging across the floor. Well, there's a lot of effort. You can just really imagine how much effort it takes to spin those reels and to move that wire across that floor. That's incoming tension. This is not what we want to do. Those days are gone. We want to take new ways of putting the wire on the reels, like you see in the bottom picture here, our SIMpull reel, that we're going to get that wire right up close to that pull point. So there's very little effort to move that wire off those reels, and that's what we want. So incoming tension, we're going to assume in our pull calculator that you're going to be using methods that gets that pull close to the pull point, okay? As I said earlier, when you do this, this is the result you get. You go from these pulls where traditionally we've used 5, 6, 7 people on a wire pull and all these jack stands and so forth. And you have, 15, 16 reels of wire that you got to pull in place as compared to if you use a solution from Southwire like the SIMpull reel that you've seen. I'm sure most of y'all have seen this, and you stack and parallel all this wire on this one reel, you're just really reducing the manpower it takes to do these wire pulls. So that's what we're going to see. And these wire pulls are going to be fast and easy. Okay. We're going to pull further than ever before, right? So we've got to be code compliant in anything we do. Well, most of you that are in the electrical business, if you're an electrician for sure, you know I'll call it 360-degree rule that says I can't exceed more than 360 degrees of bend in a conduit run. If I do that, I've got to install a pull box, right? So 360-degree bends would be the equivalent of 490-degree elbows, let's say, or any combination of elbows that get you 360-degree bends. Well, that's the code rule, but you know what? We don't have to, we can pull further than that. We don't have to set that pull box and make that the point that we pull it out and backfeed it. You see in this bottom picture, these folks that built this raceway, they put a very small handhole in the ground. And what they did here is the wire's coming up out of these conduits, and they've got to pull it out on the ground, tail it out on the ground, and then come back and feed it into these other conduits. Or they've got to cut it and splice it right there. That's not what we want to do. We want to be able to pull straight through that box. Had these folks understood the pull calculator, this would not have been done. They would have done what you see above right here. This is an example of an underground pull where the pull box is in the conduit run, but the wire is being pulled straight into one side and straight out the other side. Those conduits are directly across from each other in that pull box. So nobody's doing anything in that box. In fact, you can see in the top picture, that top conduit, there's the head of that feeder passing through that box, going straight through. So we can go through 6 or 7 or 8 90-degree elbows without splicing it or backfeeding it, and we accomplish that by putting a straight through pull box in the middle to meet code. So let's take a look at a pull here, and we're going to jump into the pull calculator and actually do a pull calc here and show you how it works. So would you ever attempt this pull? This is a very, very difficult pull. We've got 455 feet, it's a long pull. We got 4 600s, 250 ground, copper THHN, and we have 7 90-degree bends. Okay. And if you look at this a little closer, if we look at it in the form of a little conduit layout, here we have at the bottom panel board A, and way down here somewhere we have panel board B, and this is 455 feet, 4 600s and a 250 ground. So down on this end is where we're going to set up our reel. Up here on this end is where we're going to set up our wire puller. Okay. And we're going to make these pulls. So let's kind of go through the anatomy of this thing and the direction it's going. First of all, that wire has got to go up out of the top of panel A. It goes vertically. Segment 1 goes vertically 10 feet up, straight up. Then we turn in the horizontal direction, and we're going to travel in segment 2 130 feet. Then we're going to turn back down again, Segment 3 is going to drop 20 feet to another 90-degree elbow. We're going to turn back in the horizontal direction in segment 4 and go 40 feet. We're then going to turn horizontal again, travel 180 feet in segment 5, and you get the drill. Segment 6 is 15 feet. Segment 7 is 40 feet. And finally, our last segment 8, we drop down 20 feet into the panel board that we're feeding into. So a pretty long, difficult pull. Well, first thing we've got to do, I've said we're going to do this in one shot. So how do we make it code compliant? Well, if you did this the traditional way, we'd put in a pull box at this 90-degree bend. Well, by doing that, what we've really done there is we've turned this into 2 wire pulls. We've turned it into panel A, from panel A to the box, and then from the box to panel B, which means that at this box, we've got to pull that wire out in the floor or across the dirt and then backfeed it the rest of the way into that pipe in 2 pulls, or we've got to cut it in 2 and splice it right here. Neither one of these we want to do. So let's not do either one. So let's get rid of our box and instead let's put in a 90-degree elbow at this point. Okay, so there's our elbow. And we're going to pull this in one shot, but we've got to make it code compliant. So let's take our pull box and put it here, somewhere in that horizontal run in segment 5. And that box is a straight through box. So we're now code compliant, and we're going to figure out how to pull this in one shot. Okay, so I hope that makes sense to you. So if y'all kind of keep that image of that in your mind, and what we're going to do here is we're going to shift gears, and I'm going to share with you our cable pull calculator. Okay, and Elizabeth, everyone see that? Joe, anyone see the pull calc?
Yeah, it's up, Johnny.
All right, good, thank you.
Sorry,
right,
Johnny,
so-
had to unmute 2 things.
Oh, that's okay.
But yeah, it looks good.
All right, so let me get this out of my way here for a moment. All right, so here's what we're going to do. We're going to take the cable calculator, and I've gone ahead and preloaded this with the pull that we were just looking at, right? So the thing that a lot of folks look at this and they go, oh gosh, this is complicated. I'm going to zoom out here just to see the overview of this thing. It's really not. It's kind of in 4 major pieces, really. At the upper left up here is where we're going to tell it some information about our wire and conduit. The upper right up here is where we're going to get some information we may need, such as voltage drop and some information about our wire if we need it. Down below here, this bottom segment is where we're going to actually put that run in. Those segments of that pull are going to go in here. So I'm going to zoom into this top left corner. Hope I don't make you seasick here moving around. All right, so hopefully you can see that fairly well. The thing that you do here is only the things that are in purple that we have to plug in here. So if you see here from our wire pull, we had 4 phase wires. We had 3 phases and a neutral. They were all the same size, and I can choose my wire: copper THHN, copper X. I've got aluminum. I've got USC. I've got our SIMpull products. And by the way, we have down below a tab for power cable. If you're doing medium voltage, it works basically the same way, but we're going to focus on our 600-volt cable for today. So we choose our wire, and it was copper THHN, and we set our phase conductors were 600 MCM, and our ground wire here we said was also copper T, and it's a 250 ground. So again, you have all your ground sizes to choose from. So I'm done. Now, if I want to know what that reel is going to weigh, the things in yellow are where I can get some more information if I want to. I don't have to, but I can. In this case, let's do that. We said this run was 455 feet. Now we know that reel weighs 4,168 pounds, and it's going to be on a 34-inch wide by 60-inch tall reel. So this now allows us, if you're paralleling up this reel, to know what that reel is going to weigh, to know how big that reel is going to be, so you can make those decisions on your job site on how to handle that reel, okay? Because this is going to be all parallel in one reel. You can choose your ground wire if you want to, your ground wire size, but that was given for us. So down here, we can go choose our raceway type. And if I do my pull down here, I've got all my different raceway types. And yes, it makes a little difference because raceway inside diameter of the pipe can vary depending on the raceway size. So I've got EMT, got PVC schedule 40, rigid aluminum. I have fiberglass if you run any fiberglass. I even have cable tray down here. So let's go with EMT. All right. So our raceway size is size for us based on NEC. Minimum size is 3.5 inch. So let's just leave it at that. So these conductors will fit in 3.5 inch. So pretty quick and easy. We gave it the information we need to make this pull. Okay, what next? Let's scroll on down and let's look at the meat and potatoes of things here. And you'll see here that we know the coefficient of friction is set for us at 0.14. That's the coefficient of friction or the measurement of the slickness of our SIMpull THHN wire. And that's very significant. And I want you to be aware of the fact that we measure this, we test it, we know what it is, and we can calculate off of it. You'll see some competitors put some information out there about their coefficient of friction that may be misleading. You think it's not much different when in fact it really is, and we're going to demonstrate that here in a minute. All right, a sidewall pressure we said here is 1,000 pounds. It tells us that. And our pull tension is 10,000 pounds. So we've kind of set the stage. So down below, again, I've gone ahead and pre-filled out these segments of this conduit. If you remember the first one, we said we went up. We went 10 feet. So we plugged in 10 feet here and we put in a elbow. And you have all your different bends of elbows. I've got 45s, 22.5s. You've got all your different elbow bends, but everything we're using here is 90s. So as you put that segment in, and segment 2 here, here's segment 2. You remember we turned in the horizontal direction, as if maybe we're going through the ceiling of a building. And that segment was 130 feet to a 90. Next segment, we traveled down 20 feet to a 90. You get the drift. We're just popping in these straight segments from fitting to fitting through that elbow of this conduit run. Okay. So you see on the right here is the information it's given us. This is where it's calculating our continuous tension here, our pulling tension, and here's where it's calculating our sidewall pressure. Okay. Now we're looking for things to turn red. If it turns red, we got an issue. Okay. And in this case, we do. If you look at our tension here, you see the further we go in that raceway, the more tension builds up. Why is that? Well, weight, right? Weight going through that conduit run. Okay, so we get down here to this segment and we've got 2,736 pounds. That's not a hard pull. That's fairly easy for a wire puller to do. That's not that difficult of a pull. Okay. Now let's take a look at the sidewall pressure. And you remember this was the pressure going around these elbows. The further we go, the more pressure builds in each elbow. And the reason being is we're pulling the weight of that wire through more and more conduit till we get to segment number 6 right here, and boom, we're over 1,000 pounds. Okay, so that's a problem. We got to get the red out, and the last 2 segments we're up as well. So we're not going to go back and put a junction box in. If I wanted to go in and put a splice box, I could go right here and drop in a splice box, and boom, I got it fixed. But there again, I've turned this into 2 pulls, so we do not want to do that. We want to leave it. We want to make this pull in one shot. All right. What are the things that we can do to make this pull easier? What are the things that we can change to make this pull go easier and be able to do it one shot? Anybody on the call have any suggestions? If you do, unmute and let's discuss it. What do you think? What can we do to this? Well, I'll get you thinking. What about raceway size? What if we go to a bigger conduit? Who thinks that's going to make it better? I'm going to assume everybody said, yeah, it's going to be better. Well, let's go see. We look here, we're at 2,736 and we're at 1,532. Okay. Let's go up here and see what happens if we go from 3.5 inch up to 4 inch. Okay. What'd that do for us? You notice that the tension did not change at all, because that wire doesn't care. That wire is laying in the bottom of that pipe. It doesn't care how big that pipe is. It's that wire sliding in on the sidewall of that pipe. So that doesn't change. Pulling tension doesn't change. However, your sidewall pressure over here went down slightly. Who can tell me why it went down slightly? Anybody want to unmute themselves and tell me? Got a guess? Feel like I'm on Jeopardy here. Okay, no guesses. Well, how about the radius of that elbow? We went from 3.5 inch to 4 inch. Well, that 4 inch elbow has got a slightly longer radius than a 3.5. So it made a little bit of difference. So we're kind of onto something here. So generally speaking, it's a myth to say that going up in conduit size is going to make the pull any easier. So let's go back here to 3.5, which is where we were at. What else could we do? Well, does it make any difference which end we pull from? Well, the answer to that is yes, it does. So what if we, instead of setting up the wire at like where we had it at panel A and the tugger at panel B, what if we swapped it and fed the other direction? Well, we got a button over here that says reverse pull. So let's reverse that pull and pull it the other way. And let's see what it does to our tension and sidewall pressure. Wow, that didn't help us, did it? In fact, that made it significantly worse. So it does matter which way you pull the wire. So on these big wire pulls, when you run this pull calculator, even if you're not in the red and the pull's fine, you can reverse a pull and decide, if you have that option, you can decide which end you want to pull from, because if it's an easier pull going from the other end and you can set up your tugger down there instead, it's going to make a lot of difference in the time it takes to make those pulls. You might cut your time down by a third because that tugger's not working as hard and that wire is going to move through that pipe faster. So it's a big deal. All right, so let's put it back because that didn't help us. What else can we do? What if we change the radius of the elbow to see if that would help us? So let's go where we have a problem right here. And let's take this standard radius elbow. You see we have radius inches here. Standard radius would be a standard elbow you'd buy from your local distributor. Okay. What if we went with a 36-inch radius instead? Well, that's a common radius elbow that distributors are going to stock. So let's select it and look what happens. Boom. Look at the difference it made. So let's go to this one and do the same thing. Boom. So just by putting in 2 long radius elbows at the right spot, that fixed our problem. And it made it significantly easier to pull. Okay. So you can start making these decisions and turn that impossible pull into a very, very possible easy pull. This is an easy pull. This is not going to be a difficult pull. Okay. So
Johnny, I got a question. What if that was already in the ground? What problems would that cause?
Well, you read my mind. So that's as I showed you earlier. If you've already got this pipe in the ground and you have standard radius elbows, you're stuck. You're either going to be digging up pipe to replace elbows, or you're going to be pulling out and back feeding, or you're going to be splicing. So the point made here is when you get these bigger pulls on your job, even if you don't have it run, go ahead and approximate what you're going to be doing and take this calculator and build that pull and see what you got. It'll make a huge difference in your life. We've got case after case after case of contractors. Story I tell a good bit. We had a contractor call up and they had pulled some medium voltage cable and got 2 runs stuck. And went back and did the pull calculator. And said, give me your geometry on your run. Let's see what it looks like. So I did it. And with the cable they were using, which wasn't our cable, they were in trouble. There's no way they could make that pull. So they lost 2 runs of medium voltage cable. They had to chop out and throw away, basically scrap. So they bought the cable from Southwire because with the pull calculator here, our cable would pull, and they pulled it in one shot and had a successful pull. So it makes a huge difference. Don't get caught in that situation where you have a problem. And if any of y'all on the call here have been in the field, you've seen pulls get stuck. They usually get stuck in that last 90, and it's because of that sidewall pressure. That's what happens. So we're assured here that this pull, we won't get it stuck. So, all right, I'm going to, excuse me, I'm going to change these back to standard like we had it because I want to demonstrate one other thing here to you. we talk about coefficient of friction, and then we say our THHN is 0.14. Well, that doesn't mean anything to you or me, really, either. Really, it's a number. It's a calculation. All right. So what happens if someone comes along and says, look, south wire is 0.14, but our wire is 0.17. We think our wire is 0.17. Well, first off, I can't calculate off. I think it might be, so there's no way of knowing. But even if I did, let's say that we went here and went from 0.14, let's plug in 0.17 and see what happens. Bam, look at the difference it made. So the point I'm making here is don't be fooled by slight change in coefficient of friction. That slight change in coefficient of friction makes a huge difference in that wire pull. We've seen that happen many times where someone would do a pull calc based on our calculator here in our wire, and they call up and say, hey man, we're having a tough time, or this wire got stuck. And we go out to the job site, and guess what? They bought somebody else's wire. So don't be caught in that. If you use somebody else's wire, you've got to make the appropriate changes here to be able to do it. So just know that. So let's go back to point
Hey,
1.
Johnny, you
Yes, sir.
brought something up that I want to address. This just came up a couple of weeks ago when I was at a contractor. We're starting to see some of the shortages out there where they may not can get a color wire, from us or somebody else, and they're substituting a certain color. That's an issue you need to address because, again, you need to calculate it on your worst case scenario. So if you do have, say, our wire with maybe 2 other manufacturers' wires mixed in there because of shortage right now, that's something that contractors need to consider.
Yeah, if you're using anybody else's wire, all bets are off with this thing. So
Yeah.
you're
So
on
I
your
would
own
use
at that point.
I would use the higher coefficient of friction to be safe. So, use the 0.17, even though you've got our wire mixed in there with it, just to be safe. If they are having to substitute because of color, we're in a unique situation right now in the market where some people are having to do that. So just a fair warning out there for people on the line is to make sure you use the higher of the two, or
And
if
you're using standard black jacket wire, and we still sell it because people still buy it. But if you're using standard black jacket wire from us or anybody else, that coefficient of friction is going to be 0.35. Folks, you're not making this pull no matter what you do. So the difference between SIMpull wire and non-SIMpull wire is, you're looking at 85,000 pounds of tension. You're not making that pull. So just be aware of that. And, you say, well, I'm going to put lube on that wire. Well, if you do, there's no way of knowing how well that wire is going to be lubed. You're not going to get lube on every square inch of that wire, and you're not going to get lube in every one of those elbows. So what happens is you start pulling that wire, and suddenly the guy you had lubing that wire missed a foot or two, a couple of feet or 3 feet of it somehow, and that goes around a dry elbow in that pipe, and you're stuck. So anyway, just want to point that out. So let's go back to 0.14. All right, what else could we do here? If you ever get asked to go from copper to aluminum, nowadays there's kind of a more, I guess, cost difference between copper and the equivalent size of aluminum. So let's say, well, what if we went with aluminum? Well, let's go up here, and instead of copper, I'm going to go down and choose aluminum THHN. Okay. Well, the tool knew that we needed to go to 900 MCM aluminum. Okay, so it changed it to 900 MCM aluminum. Our ground wire stayed the same. You think, well, I got to have a bigger conduit. Well, guess what? It still fits in that 3.5-inch conduit. So I did not have to go up in conduit size. So you'll be able to know right away whether you have to increase conduit size. Sometimes you will, but in a lot of cases you do not. And that's because of the stranding and the way that compact aluminum is stranded. Let's go down and see what it did to us here. Look how much less the pulling tension and sidewall pressure is with 900 aluminum versus 600 copper. And you think about that. Why is that? Why is that much bigger wire, much easier to pull than the smaller copper wire? And it's simple. Weight, that 900 aluminum weighs a lot less than that 600 copper. So we've seen situations where maybe you've got a duct bank that even the best effort, there's no way you can do it without splicing. And you call up the engineer and say, look, if we run this with the equivalent size of aluminum, we can make the pool without splicing it. And the engineer will say, you know, by choosing between copper with splices or aluminum with no splices, a lot of these engineers are going to choose aluminum with no splices. So, all right. So I'm not going to go too very much further into this, but I just wanted to show you what you can do by planning these pools, doing this pool calculator. Again, you're going to assure that you're not going to get that wire stuck. You're not going to damage the wire, and you'll be able to, when you get through with this pool, if we go back up here, let's go back and put this back to copper. And we're going to go back down here and fix our problem with our 2 elbows we had so we can make that pool. And, you know, if you're on a project, and we see this more and more, where the engineer on a project says, Mr. Contractor, I want you to submit to me pool calculations on these pools. And they're requiring it. You see this on critical power jobs, data centers, hospitals, a lot of government work now. More and more engineers or more owners are asking for pool calcs. Why? Well, the reason is they want to be assured that the electrical contractor is not going to damage that wire as they're pulling it in that raceway. They're looking for a reliable installation. You know, you may pull a wire into a raceway and exceed sidewall pressure or pulling tension, and you test that cable before you terminate it, and it tests out, it megs out okay. Even if you high pot it, if it's a medium voltage and it checks out okay, you may have damaged that cable and didn't know it. And 3 years down the road, that's where that cable fails and it blows up. Because over time, that defect you created in that cable is going to get worse and worse and worse until it eventually blows. Okay, so very important. When you need to do that, we've got a button that says show. I click that, and it creates the report that I can submit to the electrical engineer for this pool calc. Okay. And again, you can put your own logo and your company, your job name, whatever you want up here. It even drew a little sketch of the pool down here for that engineer. Okay, great tool. There are a lot of other information up here. A couple things I'll kind of quickly point out. I don't want to go too long today. Voltage drop, if you're asked to do voltage drop, which many times you are. Well, first of all, we got to look at adjustment for number of current carrying conductors. We got to do that because we have a neutral here. Okay, so our ampacity now is 380 amps on this wire, and amperage at load, if it's a 3-phase load and we know this has 300 amps on it, for example, then it's telling me I'm 2.4% voltage drop. Okay, so you'll be able to do your voltage drop calcs from here. You can do it based on the ampacity of the wire, which is 380 here, or you can, if you know what your load is, plug it in and you got it. Okay. Couple things here that are important. You've got a lot of information over here that will help you on your wire pool. And there are a couple here that's important. This one is called minimum bend radius. This particular cable, it's 5 inches. You can't bend that cable in a radius smaller than 5 inches. If you do, you can crack that insulation and cause problems. And I'll point this out to make you aware. If you get into doing medium voltage pools, always look at that minimum bend radius, because you don't want to put in elbows that's too small, which is usually not the case. But if you're going around a sheave wheel, let's say you're pulling through a manhole and you, for whatever reason, you have to go around a wheel, you can exceed that minimum bend radius and not realize it and void that cable. We had a situation of that happened not too long ago. The engineer saw the contractor pulling around a sheave wheel and said, fellas, I hate it, but you've exceeded minimum bend radius, pull it out. So just be aware of that. It's very, very important. And again, I mentioned the calc power cable over here. Again, it works basically the same way. Up top here, you're just choosing your different wire size, whatever it may be. You're choosing your metal, copper, aluminum, single conductor, 3 conductor, whatever it may be. You're pulling your voltage class. You have, let me make this a little bigger. Your voltage class. You have your your 5 kVs, 15 kV. And by the way, this is all SIMpull insulation on this wire. You know, if I wanted a 5 kV 133 tape shield, there it is. It's not going to be an armored cable, simple jacket. And so now I can do my calculations the same as I did before with phase conductors. If I had 3 phases in here and whatever ground wire, I don't know, I'm just guessing at a ground wire size here. Let's just put a number, I don't know, number 6 in there. So it works the same way. So now I'd go down here below and again put in my segments and do the calc. And as I said over here at the top, it's going to give me that information I need on this particular cable. And you need to make sure that your minimum bend radius of this cable is 10.44 inches on this one. Okay. All right, so that's pretty much where I wanted to get to. There's certainly a lot more in this, but I wanted to stop here and just open it up and see if y'all have any questions on this, or do you have any jobs coming up? I would tell you, if you have something coming up where you see this would benefit you, what I'd like you to do is to reach out to your local Southwire rep to help you with this. Look, you don't have to do this yourself. We have agents around the country and distributors that handle all our products that know how to do this. They can help you on that job. So don't feel like you're that you look at this, you go, oh, I'll never be able to do this. You don't have to. We got folks that can do it for you and help you with, well, you back up, not do it for you, but assist you with it and show you how to do it so you can do these pull calcs. We have contractor solutions professionals around the country that know how to do this and do it every day. We train our distributors, our agents on how to do it. So reach out to someone at Southwire when you see an opportunity to do this on your project. So with that said, if y'all feel free to jump in and let's talk about this if you have any questions on it, or if you got something coming up that you got a question about, let's talk about it. We got a few minutes left here.
Hey, Johnny, just to add the caution to that, the minimum bend radius for the wire, right? Where people get hung up is particularly with those wheels, like we're used to talking about the bend radius of conduit, but the wheels are sold by diameter, right?
Mm-hmm.
So like that last example you said, it was a 10-inch bend radius for the wire. A lot of people go, I need a 12-inch wheel. So that's a 12-inch diameter. It's only a 6-inch radius. You probably need to jump up to a 24-inch wheel for that, or ship. And that's something where, just by not paying attention to that little thing that comes after the number, you put yourself in a world of hurt.
Absolutely. And another caution is if you're pulling medium voltage cable and when you're coming out of that raceway and you've got a wire puller sitting there, and maybe you've got a small roller on that knuckle of that wire puller and you've got a severe angle with it. If that wire comes across that roller, that puller, you could exceed the bend radius on that as well. So every bit of that cable past that roller would be not usable. So be cautious when you're coming around your puller when you're coming out of your pipes as well. Another one while we're looking here that's important: minimum installation temperature. Okay, that's an important thing too. It's for us down here in the South, it doesn't affect us. We're usually looking for a shade tree instead of somewhere to keep warm. But if you're up north, you're in Minnesota, or you're up in the Northeast somewhere, and you get in those cold temperatures, for example, this particular cable, this 5 kV cable, has a minimum installed temperature of 14 degrees Fahrenheit. And if that wire sits outside for overnight and it's cold and it's below 14 degrees, and you are stuck having, and I feel for you if you're having to work in that kind of weather, but if it's that cold, you can damage that wire pulling it in the pipe. Plus, cold wire, let's face it, it's harder to pull. It just is. It actually has a slight impact on the coefficient of friction. So be aware of that. Now, you can take that wire if you've got a conditioned warehouse, put it in the warehouse overnight, and when you're ready to pull it, if you're stuck having to work in those conditions, take that warm wire out, set it up, and pull it before it gets cold, before the wire gets cold, and you can do that. But just be aware of that. Now, if you go to a XHHW jacket, you're going to have a much lower install temperature, which is why you see a lot of engineers specify XHHW up north. But you know, the reality of it is THHN today equals or outperforms XHHW in about every category. But however, it does have a lower minimum install temperature. Any folks got any questions out there?
It looks like it's, no, never mind.
All right, let me unmute. Sorry, I was going back to the, the check boxes, Johnny, on the 600 volt for the pull boxes.
Mhm.
Explain that, that pull box is there. You're just going straight through it. The 360 rule.
Yeah,
A lot
no,
of people get
it's-
hung up on that and where to check that box, but you're not. The box is there. You're just not checking that box on the outside there.
So this is to check, this, it says right here, begin new pull at this segment, right? So this is really not then put in a box. This is saying begin a pull. Now you, in reality, would have a box there probably, but to Bill's point, that's what that means. We're looking to not create a new segment here.
Yeah.
Well, if anybody out there, if you have any desire to learn more about this, give us a shout. We'd be glad to sit down with you, one-on-one and kind of take you through this thing. Or if you have a job coming up, reach out to us and we'll help you on it. But other than that, if we have any more questions, if not, we'll adjourn. Elizabeth?
Yeah, Johnny, I want to add two things. I've had two contractors in the last month that have done pulls and not looked at this calculator. And they could done the pulls with an XD1 because that's how low the tension was. But they were worrying about how they could set up a 6K. One went for a week and a half arguing how they could set it up. And when they finally did the calculations, 255 pounds. I'm like, guys, don't even worry about a 6K. You can do this with an XD1 because you're only going 55 feet, through 290s. But they got hung up in that mindset of I've got to use a feeder puller. That's the thing that they get into. And that's where the value of this is. It allows you to select that equipment that's most efficient on the job.
Yeah, and you see situations, especially you see this a lot on underground pools, duct banks, and so forth, where the engineer will specify long radius elbows for everything, or the contractor will say, well, I'm concerned about pulling it, so let me use long radius elbows everywhere. Well, there's no point in doing that. Now you know where to put them. So just as an illustration here, if I change this back to standard, and let's say I went up here to this first elbow, let's put a long radius here, see what it does for us. Well, boom. Well, it helped us in an elbow that we didn't need any help, right? So don't waste time and money putting in elbows where you don't know. I had one a while back that, believe it or not, they'd use long radius elbows in every elbow except the last one going into the pit underneath the gear, and they were stuck having to pull from the other end, set up at the other end. I said, fellas, you're stuck. You can't pull through that last elbow. And that was the only place they needed a long radius elbow. So you not only were they not able to make that pull without digging that thing up and replacing it, look at the money they spent. They didn't need to. So this tool lets you make those decisions to put it where it needs to be if you even need it, and you're good to go. So, all right. So I guess we're going to close. Elizabeth, you want to close us out?
Sure. Yeah, thanks everybody for being here today. We hope we have some more classes that are going to be on Thursday. So we look forward to seeing you then. And you can go to our website at southwire.com, go to services, and then SSU, and you can look at all the classes that are coming up. So we'll see you next time. And thanks, Johnny and Joe and Bill, for being here today. And
Till
thanks
next
for our
time.
audience.
Take care.
All right,
Yeah,
thanks, everyone.
bye.
Thanks.